Hi, I'm Kaishan and I will introduce my final year project in this short presentation. The topic of my FYP is deploying automatic speech recognition or ASR in short for scalability and robustness on AWS. I will touch on what is ASR in a moment because the focus of this project is not ASR but scalability and robustness of the system. Scalability is the metric to measure how easy a system or application could scale up or down according to the client demand. Robustness measures how the system copes with errors during execution. These are the topics that I will be covering in this presentation. I'll start with a brief introduction to prepare you with the knowledge needed for this project. Then I'll explain the objectives of this project. The main section will be the proposed solution and its implementations. Lastly, I'll wrap up today's presentation. So here we go about ASR. Automatic speech recognition system basically is a system which can take real-time audio or audio files as input and output the corresponding transcript. There are two important concepts to know for this project. First, the container. A container is a standard unit of software that packages up code and all its libraries or dependencies so the application runs quickly and reliably anywhere. Docker will be used as the tool to build the images of the application. And with tons of containers, we need an orchestrator to manage these containers. And that is our container orchestration tools. Container orchestration tool used in this project will be Kubernetes. Secondly, infrastructure as code or ISC. ISC is a fundamental principle of DevOps in which infrastructure is treated as code. With the prevalent cloud-native platforms and consumption of their provisioned infrastructure, the concept of ISC have been popularized. With ISC, the build is repeatable, reliable, and pragmatic. The concept of ISC is being realized using the tools Terraform and Helm. Terraform generates an execution plan for configurations and apply them to cloud to reach the desired state. Whereas Helm is an open source package manager for Kubernetes, it provides the ability to use software built for Kubernetes. The common characteristic of the Helm and Terraform is that they only require a few lines of command to build or destroy the infrastructure. A lot of the complexities are handled at the back end, requiring no human intervention and allowing users to focus on developing other key features instead. The objective of this project was to design a reliable and efficient solution to provision and unprovision the infrastructure on cloud. While ensuring the flexibility to adjustments, the steps required to build the infrastructure were streamlined and the required inputs from users were minimized. The solution is implemented on AWS using Terraform as the ISC tool. The system architecture is represented in this diagram. It may look complicated and overwhelming, but the commands required to build it is fairly simple. Terraform init and Terraform apply. Yes, just the two of them. This project uses modules by three official providers on Terraform: AWS, Kubernetes, and Helm. These are the components implemented using modules provided by AWS. These components are cloud native. In other words, if the client plans to build it on other cloud service providers, these are the components that will need to be changed accordingly. The modules will build an Kubernetes cluster, a container registry, a file system, and also the auto-scaling group. The computing nodes of the infrastructure are also built by module provided by AWS. However, not all components can be implemented by modules by AWS. There are a few vital parts of Kubernetes which AWS does not have the modules in Terraform. So with configuration, these Kubernetes resources can be launched into the EKS cluster created using modules provided by Kubernetes. With such configuration, Terraform is able to provision or cover more components of the infrastructure. Here we have network load balancer and persistent volume implemented using modules provided by Kubernetes. Finally, we have Helm chart installed using Terraform modules. Chart installed will be the chart for master and worker pods, which are responsible for the transcribing jobs. The project revolves around Terraform, a tool that makes the concept of infrastructure as code, ISC, accessible and viable. Terraform established a highly replayable workflow to build the system. The hassles of using multiple tools like terminal and AWS console to provision the infrastructure had been eliminated. The complexity of scripts will greatly reduce, accelerating the process of development, and will benefit developers working on the system. Developers can speedily provision the elementary infrastructure and start working on introducing new features to the system. Upon the completion of experiments, developers can destroy the infrastructure gracefully, leaving a cloud environment clean and neat. In conclusion, this project has proven that the concept of ISC should be the standard for architecture development in the future. With ISC, the build is repeatable, reliable, and consistent. And that's all from my presentation. Thank you.